Welcome to the ultimate simulation of our future, presented by Dark Sky Dive, where we explore the architecture of tomorrow. This is the surface of the Red Planet, a desolate and silent world that is waiting to be awakened by us. The journey begins not with a human footprint, but with the roar of engines and the arrival of autonomous machines. Touching down on this alien soil marks the beginning of a new era in engineering, fully automated and devoid of humans. The cargo bay opens to reveal the true pioneers of this mission, a fleet of advanced robots ready for deployment. These machines are designed to endure the harsh radiation and extreme temperatures that would instantly kill any unprotected human being. Their first task is to survey the landscape, analyzing the soil composition to find the perfect location for the base. Coordination is key, as the swarm intelligence guides each unit to its specific sector, creating a synchronized dance of exploration. Deep beneath the surface lies the resource we need most, the raw regolith that will become the foundation of our city. This dust is not just dirt. It is a rich chemical cocktail containing iron, silicon, and oxygen waiting to be extracted. The data is processed instantly, creating a comprehensive topographical map that will serve as the blueprint for the construction phase. The site is selected based on structural stability and proximity to subsurface ice, ensuring long-term sustainability for the future colony. Heavy machinery moves in to clear the area, removing obstacles and leveling the ground with a precision measured in millimeters. The regolith is abrasive and dangerous, but these machines are built with hardened alloys to withstand the constant wear and tear. Compacting the soil is crucial to prevent shifting and settling once the heavy structures are printed on top of it. With the foundation prepared, the focus shifts to mining, the essential process of gathering the raw materials for construction. Tons of regolith are scooped up every hour, feeding a continuous supply chain that will not stop until the city is built. This conveyor system is the lifeline of the operation, transporting the raw earth to the processing plant for immediate refinement. The processing plant is a marvel of chemical engineering, designed to separate useful elements from the waste rock and dust. Inside, the raw material is pulverized into a fine powder, ensuring a consistent texture for the chemical extraction process. Magnets pull iron from the stream, separating valuable metals that will be used for reinforcing the structures later on. The refined powder enters the kiln, where extreme heat is applied to change its chemical structure and prepare it for melting. At thousands of degrees, the rock turns into a liquid magma, a printable material that is stronger than terrestrial concrete. Special polymers are injected into the mix, enhancing flexibility and tensile strength to withstand the pressure differences on Mars. Vacuum chambers remove every bubble of gas, ensuring the material is perfectly dense and capable of holding an atmosphere. The liquid building material is pumped through heated pipes, delivered directly to the nozzles of the waiting 3D printers. The construction robots take their places, giant 3D printers that will sculpt the city from the very ground beneath them. The first layer is laid down, a geometric hexagon that offers the best balance between structural strength and material efficiency. Rapid cooling technology ensures the material hardens almost instantly, allowing the printer to build upwards without waiting for drying. Multiple units work in parallel, a swarm of builders that accelerates the timeline and ensures redundancy in the process. The walls are printed with a hollow internal lattice, providing excellent thermal insulation against the freezing Martian nights. Before the walls are sealed, smaller drones embed the nervous system of the habitat, the electrical and plumbing lines. From above, the base looks like a honeycomb, a natural design that maximizes space while providing incredible structural integrity. Even as the sun sets and temperatures plummet, the machines do not stop, fueled by nuclear batteries and relentless logic. An outer shield is applied, a dense layer specifically formulated to protect future inhabitants from deadly cosmic radiation. Windows made of transparent aluminum are slotted into place, offering a view of the landscape without compromising safety. The printers now tackle the most difficult task, closing the dome, creating a seamless seal against the thin atmosphere. With the final pass of the nozzle, the habitat is sealed, separating the interior environment from the harsh vacuum outside. Nearby, a massive solar farm unfolds, capturing the weak solar energy to power the life support systems and machinery. Dust is the enemy of solar power, so automated cleaners constantly sweep the panels to maintain peak energy efficiency. For the long nights and dust storms, nuclear microreactors provide a reliable baseload of power that never falters. Inside the shell, the life support systems roar to life, pumping a breathable mixture of nitrogen and oxygen. Sensors monitor the air quality, ensuring that the pressure and composition mimic Earth's atmosphere at sea level. With the atmosphere stable, interior robots begin the fit-out process, turning the empty shell into a livable home. Food production modules are installed with vertical farms, ready to grow fresh crops using recycled water and nutrients. Every drop of water is precious, cycled through advanced filtration systems that reclaim moisture from the air and waste. Laboratories are equipped for geology and biology, preparing for the scientists who will soon call this place home. Comfort is not a luxury, but a necessity, with living spaces designed to support the psychological well-being of the crew. Private quarters offer a sanctuary for rest, compact yet efficient, providing personal space in a communal environment. High-gain antennas lock onto Earth, bridging the millions of miles with a stream of data and communication. The central computer confirms that all systems are operational. The habitat is now a living, breathing entity. Half of the initial phase is complete, a testament to the power of autonomous construction and human ingenuity. Below the surface, tunnels are bored to connect the habitats, creating a safe underground network shielded from radiation. These tunnels are reinforced and sealed, allowing crew members to move between buildings without suiting up for outside. Lighting is installed to mimic natural circadian rhythms, helping the crew maintain a healthy sleep cycle underground. But Mars is not welcoming. Dust storms can envelop the planet for weeks, testing the limits of our engineering. The structures are aerodynamically designed to let the wind pass over them, minimizing the stress on the walls. External operations cease as the robots retreat to their shelters, waiting out the storm in safety mode. Inside, the storm is just a muffled sound. The environment remains stable, warm, and safe for the future inhabitants. As the skies clear, the workforce emerges once again, relentless and tireless in their mission to build. Now construction begins on the landing pads, preparing for the arrival of the first human colonists from Earth. Precision markings and guidance beacons are installed, ensuring safe landings for the massive starships that will follow. Fuel storage is critical. We are building the infrastructure to refuel ships for their eventual return journey to Earth. This plant uses the Sabatier process to turn Martian air and ice into rocket fuel, enabling a round-trip economy. Safety is paramount. Automated fire suppression systems are tested to ensure they can handle emergencies without human intervention. The medical bay is equipped with robotic surgeons capable of performing complex procedures guided by doctors on Earth. In low gravity, muscle atrophy is a risk. Specialized gyms are built to keep the crew strong and healthy. Nothing is wasted here. Every scrap of material is recycled, turning waste back into resources for the colony. The outpost has grown into a village, a beacon of civilization standing alone in the vast red desert. Scouts return from distant regions, bringing data that will help us understand the history of water on Mars. A central AI governs the entire city, optimizing energy, water, and labor to ensure maximum efficiency and safety. This is just the beginning. The plan is to scale this model, expanding from a base into a city. Large biodomes will eventually house forests and parks, providing a psychological connection to the nature of Earth. Transport tubes will connect distant mining outposts, creating a high-speed network for moving goods and personnel across the planet. Looking up at the night sky, we see a pale blue dot. Earth, our home, watching us from afar. The waiting is over. The infrastructure is ready, and the first human pioneers are beginning their descent. They arrive not to a barren wasteland, but to a fully functioning home built by the silent labor of robots. Stepping onto the surface, they see the realization of a dream, a sanctuary forged from the red dust itself. The walk to the airlock is short, but it represents a giant leap for the continuity of our species. Entering the airlock, the dust is washed away, leaving the harsh environment behind and entering the world of humans. The helmet comes off. The air is cool and fresh. For the first time, humans breathe safely on another world. This moment is the culmination of decades of research, engineering, and the relentless pursuit of a multi-planetary future. Work begins immediately. Humans and machines now collaborate to maintain and expand this foothold in the cosmos. Life here settles into a rhythm. It is a hard life, but one filled with purpose and discovery. Exploration continues, but now with human eyes and human intuition guiding the search for life and resources. We search for answers to the oldest questions. Are we alone? Did life once thrive on this rusty world? Every sample analyzed brings us closer to understanding the history of our solar system and our place within it. The beauty of Mars is alien and haunting, a reminder of how far we have come from our cradle. This base is more than metal and plastic. It is a seed, planted in the dark, waiting to grow. As the launch windows open, more ships arrive. The population grows and the city expands across the plain. We move from survival to sustainability. Factories now produce spare parts and tools directly from Martian resources. We prepare for the future generations, those who will be born here and will know Mars as their only home. Culture evolves with the environment. New sports and arts emerge, shaped by the unique gravity of this world. The green lungs of the city breathe life into the stale air, a piece of earth transplanted to the stars. Water, once frozen underground, now flows freely, supporting a delicate ecosystem that sustains the colony's spirit. From orbit, the lights of the city are a testament to human resilience, a new constellation on the surface. A web of satellites surrounds the planet, connecting every explorer and ensuring we are never truly alone. We look outward again. The moons of Mars, Phobos, and Deimos become the next stepping stones for our expansion. Mars becomes the gateway to the asteroid belt, a hub for mining operations that will fuel the solar system. The city grows upwards. Skyscrapers pierce the thin atmosphere, monuments to what we can achieve when we unite. Robots remain our partners, the silent guardians that maintain the life support systems while we focus on living. We remember the beginning, the first automated ships that touched down and paved the way for everything we see. For the children born here, Earth is a story, a distant blue star in the sky, a myth. They are the Martians. This harsh red world is their nature, their playground, and their inheritance. But the dream does not end here. The long-term goal is terraforming, turning the red planet into a green planet. We will thicken the atmosphere, warm the planet, and release the water trapped in the polar ice caps. Water will flow once again across the surface, carving new paths and bringing the dormant soil to life. Simple plants will be the first to colonize the wild, turning the red oxide into rich, black, fertile soil. Slowly, the sky will change. The dust will settle, and a blue canopy will embrace the world below. Forests will rise, genetically adapted to the cold, producing oxygen and transforming the landscape into a living biosphere. One day, we will walk the surface with only simple breathing masks, feeling the wind on our faces. It is a project of centuries, a cathedral of planetary engineering that will take generations to complete. But today, we start with the basics. We start with the dust, the machines, and the will to survive. Every layer printed is a step away from extinction, a step towards becoming a true multi-planetary species. This vision is driven by the belief that the light of consciousness must not be extinguished by a single event. The connection between Earth and Mars will remain strong, a bridge between the cradle and the new frontier. As we leave the orbit, we look back at what we have built, a testament to courage and technology. Mars is just the beginning. The universe is vast, and humanity is just taking its first steps into the dark. We hope you enjoyed this journey into the future of construction and colonization on the Red Planet. Thank you for watching Dark Sky Dive. Join us next time as we continue to explore the boundaries of existence.